okay? All right, so here we go. Here's the graph of cosecant. Cosecant is the reciprocal of the sine function. So literally, the easiest way to graph the reciprocal of sine and cosine, this cosecant and secant, is to think about what their original curves look like. Think about sine, think about cosine. So I'm going to give you a chart. We're still going to use our quadrantals because the period of cosecant is still 2 pi radians. It still takes 2 pi radians to complete one period and one cycle. So if I take that period and divide it up into 4 subintervals, I'm still counting by pi's over 2. So let's mark our axes. Let's count by pi's over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, and 8 pi over 2. And then I'll go back the other way. Negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, and negative 4 pi over 2. Okay? Okay, so guys, can everybody picture the sine wave? I hope you can picture the sine wave in your head. The sine wave started at 0, then it went to 1, then it went to 0, then it went to negative 1, and then it went to 0 again. So if you can picture, that was one sine wave. So picture that, okay? And then we can continue. Then it went to 1, then it went to 0, then it went to negative 1, and then it was back at 0. So there's another cycle. Okay? And if we worked backwards, it went to negative 1, and then 0, and then 1, and then we were back at 0. This is a dotted line. Okay, because I'm only doing it dotted because we're not actually graphing sine, right? We're graphing cosecant. But if you can picture the sine wave, it's literally the easiest way to come up with the cosecant's graph. All right, let me try and use a different color. So what happens is, at every ordered pair we have, this is 0, 0. This is pi over 2, 1. This is pi 0. This is 3 pi over 2, negative 1. This is 2 pi 0. At every input, at every angle, the ratio, the y-coordinate gets reciprocated because the ratio is going to be the reciprocal of sine. So guys, if you're at 0, 0, right? If you reciprocate his y-coordinate, which is 0, the reciprocal of 0 is undefined. So now it creates a vertical asymptote at 0. Now we're graphing cosecant. So when you plug 0 into cosecant, the cosecant of 0, right? Here's 0 radians. That's the sine. It's the reciprocal of that y-coordinate that is the cosecant. So the cosecant of 0 is the reciprocal of 0, which is undefined. So now we have a vertical asymptote. Okay, the next point is pi over 2, 1, right? So now we're up here at pi over 2, 1. The cosecant of pi over 2 is the reciprocal of that y-coordinate. The reciprocal of 1 is 1. So we still have the point 1, 1 on the cosecant's graph. I should say 1, 1. I should say pi over 2, 1. Right, then you go to pi 0, right? So at pi, the sine of pi was 0. So the cosecant of pi is the reciprocal of that y-coordinate. And the reciprocal of 0 is undefined. So we create yet another vertical asymptote. Okay, then we go to the next point. On sine, this was 3 pi over 2, negative 1, right? The sine of 3 pi over 2 was that y-coordinate, negative 1. So the cosecant of 3 pi over 2 is the reciprocal of that y-coordinate. So the reciprocal of negative 1 is negative 1. So you still have the ordered pair, 3 pi over 2, negative 1 on the cosecant's graph. All right, and then we get to 2 pi. And at 2 pi, we're back here full circle. The sine of 2 pi was that y-coordinate 0. So the cosecant of 2 pi is the reciprocal of that y-coordinate, which is undefined. So it's yet another vertical asymptote. Okay, so let me stop. We have gone from 0 to 2 pi. Believe it or not, guys, we have created one complete cycle of the cosecant curve. But it's like, what the hell does it look like? Well, guys, can you picture it? Everything has the reciprocal of the y-coordinate. So picture, the sine of pi over 6, which is like 30 degrees, had a ratio of 1/2. So now you have pi over 6, 1/2, that we know lives on this graph. Well, guys, what's the reciprocal of 1/2? It's 2. So that means pi over 6, now 1/2 becomes 2. So now you have a point up there. It flips, it gets reciprocated, right? All right, same thing over here. I know there's a quadrant 2 angle that gives me a 1/2 as well. So now we're at 5 pi over 6. At 5 pi over 6, the ratio for sine was 1/2. So reciprocate the 1/2 and it becomes 2. So now 5 pi over 6, the cosecant of it is 2. So guys, there's an angle right here that made this ratio come out. If you reciprocate it, now you're like up here. If I take this ratio and reciprocate it, now you're up here. If I take this ratio and reciprocate it, now I'm up here. If I take this ratio and reciprocate it, now I'm up here. So what's happening is you're basically creating a parabola that is stuck in between these two asymptotes. So now it's going to look like this. So you literally are taking this hump right here, you are flipping it up, and now it causes a parabola S figure that goes off to the infinities. All right? Well, guys, now come here. So now go in between the next two asymptotes. So now between pi and 2 pi, it used to have this little hump. Well, now everything's going to get reciprocated, and these are negative values. So negative 1/2 become negative 2. These get reciprocated, they're here. So now it's going to flip down. Now you're going to have a parabola that flips downwards. So all of these humps, this gets reciprocated up, this gets reciprocated down. So now we're on the next, right? So anytime you have an x-intercept at 0, it creates an asymptote. So all of your x-intercepts are an asymptote on the cosecant graph. So 3 pi is undefined, 4 pi is undefined, and then all of your 1s and negative 1s stay the same. And then all the other values in between flip up. So this hump, now it flips up. Now it's going to be a parabola going up. This hump is going to flip down, and it's going to be a parabola going down. All right, same thing. Come over here. Any x-intercept will create an asymptote. So I have an asymptote here where there was an x-intercept. I have an asymptote here where there was an x-asymptote. All right, an x-intercept. And now this hump flips down, and this hump flips up. So it's all of these up, down parabola type shapes. And that's how you can create the wave extremely, extremely easily. You just know that wherever you had a positive hump, flips up. Wherever you had a negative hump, flips down. Because that's what happens to these ratios when they get reciprocated. All right, so one period, one cycle was from 0 to 2 pi. Parabola up, parabola down. Parabola up, parabola down. So that's 2 cycles of the cosecant curve. Okay, let's fill in our important information. So the domain. Well, guys, what angles are you allowed to plug into the cosecant function? Well, guys, I guess I should put these in too, in case you want to know. All right, the domain. Look at all the asymptotes. You have a lot of x values that you don't want to plug into this function anymore. I don't want to plug in 0. I don't want to plug in pi. I don't want to plug in 2 pi. I don't want to plug in 3 pi. I don't want to plug in negative 1 pi. So integer multiples of pi are bad. So we're going to say x cannot be, the first bad guy was 0, and then plus or minus, they're all pi radians away from the next bad guy. Times k rotations or revolutions. All right, our period is still 2 pi. It still takes from 0 to 2 pi to create one parabola up and one parabola down. And then we're back to repeating. Parabola up, parabola down. All right, so it still takes 2 pi to create one cycle or one period. The range. Guys, look at the range of y values that come out. There's a huge gap that doesn't exist on the cosecant as far as y values. All your parabolas down, they're going off to negative infinity. But guys, look, they only come up to what y value? -1. And then remember, the black isn't on our graph. This is a huge gap. The parabola ups don't start until a y value of 1, and then they shoot off to infinity. So the y values from -1 to 1, there's a huge gap. They never come out of this function. So your range is only going to be from -infinity to -1. Union, it jumps from -1. You don't get another y value until +1, and then it shoots off to infinity. The amplitude. Well, guys, again, since these curves are shooting off to the infinity, to find like half the distance between the highest and lowest point is irrelevant. So NA. All right, the x-intercepts. Guys, we have infinitely, actually, I take that back. We do not have infinitely, we have infinitely vertical asymptotes. We don't have any dots that cross the x-axis. These graphs do not touch the x-axis. There are no x-intercepts. As far as the y-intercept, guys, it's undefined. We have a vertical asymptote at the line x equals 0. There's no y-intercept. It's an undefined output. And then if you remember, sine was an odd function with symmetry to the origin, right? For every xy on the graph, so was the point the opposite of x, the opposite of y. So just like his reciprocal sine, the cosecant is also an odd function. For every xy that lives on his graph, so does the point the opposite of x, the opposite of y. So it is an odd function with symmetry to the origin. Vertical asymptotes, guys, we got infinitely many of them, right? Every x value that is not in the domain creates a vertical asymptote. So now we would say x equals 0 plus or minus pi times k. Every integer multiple of pi is going to create a VA. All right, the subintervals. Well, it's nice when it's broken up from 0 to 2 pi. So your subintervals are 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. It's the quadrants. Quadrant 1 angles, quadrant 2 angles, quadrant 3, and quadrant 4. And then your key points that you can use to create one period or one cycle of the cosecant curve is going to be when 0 goes in, undefined came out, an asymptote. Right, that's a VA. Then we're going to go to pi over 2, 1. He's kind of like the bottom of your parabola. Then we're going to go to pi undefined is the next critical point, key point. Then we're going to go to 3 pi over 2, -1. That's like the top of your downward opening parabola. And then we're going to go to 2 pi, which is undefined, another VA. And those should be the 5 points you need to create that first cycle of the cosecant curve. So again, it just repeats. Parabola up, parabola down, that's one cycle. Now we're going up, then we're going down, that's another cycle. Now we're going up, then we're going down, that's another cycle. Every 2 pi radians. Okay? We're going to do the secant the exact same way. We're going to graph the cosine curve, and we're going to reciprocate its humps. And then all of its x-intercepts will also turn into vertical asymptotes. Because it's the same idea. It's the graph of cosine with all of the ratios, all of the y-coordinates reciprocated. All right, let's get ready for secant because I'm going to get cut off by the bell again. And I've got to get these parent graphs scrapped. All right, here we go. Last one. Last one. All All right, so guys, it's also going to have a period of 2 pi. So let's cut it into fourths. Let's count by pi's over 2. Let's get our x-axis ready to go. Okay, so if we graph cosine, remember, cosine started up at 1, then it went to 0, then it went to -1, then it went to 0, and then we will back up at 1. That was 1 cosine wave, just like that. All right, and then we were back at, oh, I should have dotted that. All right, and then we're back at 0, we're back at -1, we're back at 0, and then we're ending up at 1 for another cycle. And there's another cosine wave. And then we can go back, we're at 0, we're at -1, we're at 0, and we're up at 1. Okay? So now any x-intercepts, any y-coordinates of 0, when you reciprocate that, become undefined. All right, so let's put our asymptotes in. If this hits 0, that's an asymptote, right? The secant of pi over 2, at pi over 2, guys, the x-coordinate was 0. So that's the cosine of pi over 2, but the secant is the reciprocal of 0, which is undefined. All right, we had an x-intercept at 3 pi over 2, so that's going to be an asymptote. We had an x-intercept at 5 pi over 2, so that's an x-intercept, vertical asymptote. 7 pi over 2, that was an x-intercept, so that'll be a VA, a vertical asymptote. Negative pi over 2 was 0, so that'll be a VA. Negative 3 pi over 2 was an x-intercept, so that'll be a VA. These are all the x-coordinates were 0, guys, because when you reciprocate 0, the ratio is now undefined. All right, so now, any of your ones or negative ones, right? I had the point 0, 1. So when I reciprocate 1, it's still 1. So that'll still be a point on the secant curve. All right, pi, -1, right? -1 has a reciprocal of -1. So that's still going to be a point on the secant graph. 2 pi 1. The reciprocal of 1 is 1. So that's still going to be a point on the secant graph. 3 pi -1. -1. The reciprocal of -1 is -1. So that'll still be a point on the secant graph. And the same thing here, 4 pi 1, that'll still be a point. All right? The point -pi -1, the reciprocal of -1, guys, is -1. So that's still going to be a point on the secant's graph. -2 pi 1, the reciprocal of 1 is 1. That's still going to be a point on the secant's graph. All right, so guys, now think about it. This hump that goes up, right? When you reciprocate all of these y-coordinates, they flip up like this. So now this is your parabola going up. Just think about it. Here's 1/2. So these 1/2, when you take the reciprocal of 1/2, now they're 2's. Everything flips up. Now you have this bottom hump, all of these ratios, when you reciprocate them, flip down. So now you have a parabola going down. This hump right here, all of those ratios, when you reciprocate them, flip up. Now we have a parabola going up. This hump right here, when I take all of these y values and reciprocate them, they come down. They flip down. So now I have a parabola going down. And then this will be an up, right? This one goes, this hump down, it reciprocates, got a parabola going down. This one was starting to go up, so it will flip up and reciprocate. So the exact same thing happens. Your pattern is still parabola up, parabola down, except it doesn't start at 0. Remember, the cosine's graph was the sine's graph shifted back pi over 2 units. So it's just the exact same cycle, parabola up, parabola down, but it goes from negative pi over 2 to 3 pi over 2 to create that first cycle. All right, but that's it. You start back here at negative pi over 2, and that's where it starts. Parabola up, parabola down. Parabola up, parabola down. Parabola up, parabola down, all the way off to infinity. All right, so the domain. Guys, it also has a lot of angles that you can't plug in. The first bad one was negative pi over 2, and then pi over 2, and then 3 pi over 2, and then 5 pi over 2. Odd integer multiples of pi over 2 are bad guys. So x cannot be, I'm going to say pi over 2 plus or minus pi, because they're all pi radians away from each other, times k revolutions. The period is 2 pi. That's how many inputs it takes to create that parabola up, parabola down. The range, guys, same thing. You have all of your parabolas going down to negative infinity, but they only come up to negative 1. And then there's this huge gap where the other parabolas don't start until a y value of 1 and then shoot off to the infinity. So again, all these y values from negative 1 to 1 do not come out of this function. So it's going to be from negative infinity to negative 1, union, it picks back up at 1 and then shoots off to infinity. You have all of these y values that cannot come out of this trig function. Amplitude again is NA because we're shooting off to the infinities. So half the distance between the highest and lowest point is NA. X-intercepts, again, we don't have any. These graphs don't cross the x-axis. But as far as the y-intercept is concerned, the secant has one. It's right there. It's the 0.01. It has a y-intercept at 1, at a y value of 1. Now remember, cosine was the only even function, right, that had symmetry to the y-axis. When x goes in, y comes out. When the opposite of x goes in, the y still comes out. Look at it, guys. I can take this first parabola up and flip it. It has symmetry to the y-axis. This is an even function, just like his reciprocal. VAs, guys, we got tons of them, right? Wherever there was an x value not in our domain, it created a vertical asymptote. So all of these odd integer multiples of pi over 2, x equals them at their VAs. Okay? Now, as far as our subintervals, because we've technically been shifted back pi over 2 units, our subintervals are basically like quadrant 4 angles, quadrant 1 angles, quadrant 2, and quadrant 3. We don't get quadrant 4 angles in the positive sense on that first cycle. So our subintervals are negative pi over 2 to 0, 0 to pi over 2, pi over 2 to pi, and then pi to 3 pi over 2. And I know I have to write this small, but this is all on the filled in notes, guys. And then your key points. The key points that we can use to graph the first cycle of secant is going to be negative pi over 2 undefined, 0, 1, pi over 2 undefined, pi negative 1, that's the top of your downward opening parabola, and then your 3 pi over 2 undefined. Those are your VAs. And then this is the top of your up parabola, and this is, the bottom of your top parabola, and the top of your down parabola. All right. Woo! So guys, obviously these are not easy things to graph. We are well behind the graphing straight lines. but these are what the secant, cosecant, cotangent, and tangent graph behave like, all right? Now, what they're going to ask you to do in the rest of this chapter is transform them. What happens to their period when you stretch them and shrink them, and their amplitude, which they don't have, all right? And then they may ask you to shift it right or left or up or down so many units. We haven't seen that yet. We've only seen stretches and shrinks. We haven't seen like right, left, up and down shifts, okay? So I'm going to try to do that with you guys tomorrow, and then I'm done. And then we have to just try to figure out, like, can we review and quiz in time? But I'm telling you, it's a lot of graphing calculator stuff. It shouldn't be that bad. Okay? All right. All right, I'm going to stop there. I did create a homework. Guys, the homework it's not even like you're doing math. It's all informational. Where are the x-intercepts? Where are the vertical asymptotes and stuff like that? It's all just very informational type questions on tonight's homework. I think I made it due Wednesday just to give you guys time. All right? All right, so let me double check the attendance, and then you guys are going to be good to go. Are you guys okay here? Yeah?
Now we have a little surprise.
Studying